Okay, so I've turned my instrument on using the low resistance ohmmeter function of the tester. So this is going to be able to be used to check continuity of protective conductors. The first thing to remember is the leads will have a significant resistance in relation to the circuit that you're measuring. So first thing to do is we always connect the blue and the green together for this test, so they kind of piggyback quite easily. And I'm going to pop a couple of crocodile clips on. I'm going to put the leads together and just take a measurement so you can see what value that the leads actually are. So to take a measurement, press the test button and I can see that those leads are 1.21 ohms. If I now press the cal button, not a very good name for it, but it's like the null button, it will measure that value and then deduct it. Okay, and now if I take a test, it should show 0 ohms. 0 ohms. So the next test that we're going to do, or the first test actually, we've set up the instrument, we've checked the instrument's a good one, and now we're going to move on to the first dead test, which is C, stands for continuity. So this is continuity of protective conductors, and that's going to consider our main protective bonding conductor, which in this instance is this conductor to the water pipe, and also our earthing conductor from the supply. We then move on and do any supplementary protective bonding conductors and of course our circuit protective conductors. So I'm going to disconnect one end of the main protective bonding conductor to the water pipe, and the reason I'm disconnecting one end is to remove any parallel paths, because if there's a parallel path it could give a reading when the actual main protective bonding conductor is in fact broken and not continuous. So I've disconnected the main protective bonding conductor from the top end and the MET, and put a clip on the disconnected end and also on the water pipe itself. I'm now going to take a reading. And the reading is coming up as 0.00. It's quite low because it's only a short piece of copper, and yeah, that's all good. So there we can see it's connected to the disconnected main protective bonding conductor, and I've actually gone onto the water pipe itself. That will pick up any loose clamp connection or anything like that, so onto the pipe it's all the way through, which is absolutely better. I'll then repeat that test with the disconnected earthing conductor, and that would be the one that I would now remove here, obviously replacing that one first. So when we've undertaken the main protective bonding conductor and continuity of the earthing conductor, the best route forward then is our circuit protective conductors, or our CPCs. Now you can get the information on what the circuits are once again from the distribution board schedule, shown just here on the right hand side of the board. So what I suggest is we'll do the radial circuits first, because that's the quickest and you progress the best, and then you can see what's happening and you're making progress down your schedule of test results. I would do the ring circuits or the ring final circuits last. So the first circuit I've selected is going to be the radial socket, and you can see that I've put a wire link between the respective line conductor. So the line conductor of this circuit breaker, B16, and across there, which is also the B16, and linking up to the earth bar. So there's the kind of link fitted. And then I'm going to go to all points on the circuit and measure what's referred to as an R1 plus R2, because it's measuring the resistance of the line conductor and also the resistance of the respective circuit protective conductor up here. I've only got one socket on the circuit, so that is pretty simple to undertake. I'm going to use something called a socket interface adapter, which looks a little bit like one of these. So, useful bit of kit, little gizmo that I can plug into a socket, saves having to expose the conductors. Although this is initial verification, obviously we will have inspected the conductors behind that socket plate already. So that goes into there, and then I move my instrument. So I've moved my connections now so that my green and my blue are in the earth pin and the brown is in the live or line pin. And we'll take a reading on the meter. So I've got a value of 0.87 ohms. So that is the value that's recorded on the schedule of test results. So I've now moved on to the two-way lighting circuit, and I've done this one because it's a little bit trickier to do because obviously the two-way switching. You may have intermediate switching as well that will have an effect on undertaking this particular test. So at the bottom of the pendant we have a clip onto the CPC. And then pop a probe onto the constant line conductor. The reason for this is it helps determine if you've got the right circuit if you're not sure what the switches are. So you may have the link on the wrong circuit, so you can be faffing around for a while. If you get a continuity value on that, then we know we've got the link in the right place, and we need to get to the extremity of the circuit, which is the switch wire coming back up to the lamp, which would be that circuit at that point there. Notice I've took my tips off. GS38 leads apply to voltages in excess of 50 volts. We are testing at 24 volts with a low resistance ohmmeter. So taking the tips off actually means I can actually get contact with a screw and not get the guard or the guard tip resting on the plastic and it actually missing the terminal. So I'll take a reading like that. And my instrument is saying greater than 999. Oh. What that is indicating is that the circuit is open circuit. So that means that one of the both switches in the two-way switching is in the off position. So I'm going to operate the first of the switches and then take a reading. Value of 0.2 ohms. I'm then going to turn the circuit off and on again, the other switch. Do the test again. And I've got a figure of 0.13. So the worst figure there was 0.2 ohms. So that becomes the recorded value on the schedule of test results. It's worth also considering, once you've fiddled with the switches, and we know we have continuity up to the lamp, don't fiddle with the switches again, because you know the circuit is now closed, so that when you move to insulation resistance, you know the switches are in the right position. So firstly, we operate the first switch to close the circuit and then get a reading. Then we open that switch again and close the next switch and get a reading. The recorded reading is the highest of the two values. When you've done behind an accessory, if you don't need to be in there again, screw it back to the wall so that when the insulation resistance test is undertaken, not only is it safe, but it will also potentially pick up any trapped wires if there is a wiring fault when you squeezed a cover or squeezed an accessory lid back on. So that's another quite important thing to remember.